In this Connect with BMC Helix ITSM and Remedy webinar, we will cover FTS Indexing Technical Deep Dive. My name is Dolly Parrillo and I am the Senior TSA with BMC Support. Today's webinar we will discuss the following topics. What is FTS? What are the components of FTS? Indexing data, understanding the FT pending table, troubleshooting searching issues that are the result of data not indexed as expected, using the FTS console to monitor the health of FTS, and finally review references of FTS-related knowledge articles and documentation. So what is FTS? FTS is known as full-text search. FTS is a component of AR Server that performs fast word-based searches. These are word-based searches versus a database search. Unlike a database search, FTS does not index every character of every field and then search on those characters. FTS instead indexes words and puts those into its library of database and then looks for records that contain the word. Word indexes are stored in collection folders using Lucene as a third-party component. FTS solves problems that the database cannot fully solve, among those being it searches fast and very long text such as club fields. It's much faster than native database when searching in long text fields. It improves search performance by searching large volumes of data. It searches within attachments, which is something a database search cannot do, and it's the only method available for searching text within attached documents. It provides case-insensitive searches for case-sensitive databases, performs case-insensitive searches faster, and then combines case-insensitive searches with word searches. And then it ranks the search results according to their relevance to the search criteria. So there are four main components to FTS, and those are AR Server, the Searcher plugin, Collection Directory, and the FT Pending table. The FTS service contains an indexing service that writes and updates a set of index files and a search service that reads the index files and uses the data to perform fast searches. The AR Server, together with the FTS Searcher running in its own plugin server, is called the FTS Server. Only the AR servers designated as FTS Indexer servers service the FTS queue. However, any AR server within a server group adds to this queue when servicing an API call that alters data on a field marked for FTS. The next component is the FTS Searcher plugin. For servers that are not indexers but still need access to the collection directory, and that access is provided by the plugin. So the collection directory is a set of FTS index files contained in its own set of directories, and it's a flat file database of indexes. Events such as create, update, and delete within the AR system or server group are queued via the FT pending table in the database. The FTS server spawns a set of indexer threads, taking items from this queue to add, delete, or update the data within its index file accordingly. AR Server is responsible for detecting form and data changes that need to be reflected in the FTS database. AR Server updates the FTS queue with appropriate data and responds to the indexing requests. The indexing mechanism is based on an asynchronous queue, which is based on an internal system table in the database during the originating transaction. The originating transaction typically involves a create entry, a set entry, a merge entry, or a delete entry operation on a form where a field indexed for FTS or full-text search exists. The internal system table is also known as the FT pending table. So AR Server responds to indexing requests. A full-text dispatcher thread processes indexing tasks in real time on a first-in, first-out basis, queuing them for indexing threads to process. AR Server triggers an FTS search when an FT index field is included in a query, and it also triggers an MFS query when a global search or a multi-form search form search is performed. So the internal FTS engine periodically checks the FT pending table for work. It waits for signals from AR Server to perform work such as updating, delete, or create index entries. It waits for FTS MFS search requests and then performs the FTS or MFS query and returns results to AR Server. It performs indexing jobs based on FT pending operation. It reads data from AR Server, It read, writes, updates FT index via the collection directory. It optimizes existing FT pending entries to avoid duplicate processing. For example, if it finds a create entry and a set entry for the same entry, it will delete the older one and process only one. It updates status in the FT pending table for long-running requests like a schema index. It performs scan jobs based on form properties and FT schedule. It handles failover in case the indexer is busy re-indexing or for some reason it's unavailable. The full text search has smart processing for all the entries to be indexed. The smart process optimizes the processing of redundant entries and results better indexing performance. It provides the following functionality. It avoids processing of duplicate index requests from JMS. It avoids processing of duplicate indexing requests from JMS and FT pending. Does not depend on the JMS messaging-based communication for the FTS indexing. It uses only JMS as a wake-up signal and also adds a scheduler for any periodic missed entries. It avoids logically redundant requests by cleaning the requests from the FT pending table during the insert or processing. The system ensures that only the redundant entries are deleted from the system so that work required for these entries is completed by some other entry. It optimizes the synchronization of global or form and entry-level reindexing in such a way that the resources in the server, the CPU and threads, are optimally used for indexing. This next component we're going to take a look at is the Searcher plugin. Searcher plugin responds to search requests from remote AR servers. So if AR server is not the indexer in a server group, the AR server sends the search request to the FTS plugin, which is running under the remote FTS plugin server on the indexing server. The FTS Searcher plugin responds to search requests from remote AR server group members. FTS uses only one plugin server as a searcher. The Searcher plugin is installed on the FTS Indexing server. Only the designated indexing FTS server has a rank in the AR System Server Group Operation Ranking form. The AR server is defined as an indexer. AR System Server acts as FTS Indexer and FTS Searcher for local search requests. The Searcher FTS plugin server serves as the searcher for all the other AR system servers in the server group that are not designated as indexing servers. So you must configure all other non-indexing servers to connect to the Searcher FTS plugin server instance running on the FTS indexing server. The Searcher instance runs on a separate port on the FTS indexing server. The internal FTS engine updates the index, and the plugin only searches connecting to the local collection directory. The events that cause data to be written to the index result in data being put into the AR system database as a queue of items to index. Only the indexing server processes indexing requests from this queue. However, any instance of AR server can send a search request to its corresponding FTS plugin. This ensures index integrity. There is no search failover for the indexer AR system server. Other servers in the server group connect to the Searcher plugin server for FTS and MFS searches. Each server detects that it needs to perform an FTS or MFS search. It creates a request design for Lucene using the server plugin alias. It connects to the first-ranked Searcher plugin server. It handles HA or high availability environments. So it automatically fails over to the next ranked server if the plugin becomes unavailable. And it combines FTS results with database results when needed. Here we see an example of the FT pending table. The FT pending table is a job queue for indexing records. Every API that reflects a change in FT index data writes to this table once for each indexer server. There are different operation types depending upon the tasks, which we will discuss later in the presentation. So the collection directory contains the actual indexes. It's a flat file database that stores all of the indexes. You'll find it contains one database per form based on the schema ID, and each folder contains a set of files as seen in the screenshot. Lucene, which is a third-party product used by FTS, manages the files that make up the collection directory. The screenshot displays a typical folder and file structure. The folder name is the schema ID for the form from the AR schema table. The contents within each folder is this Lucene metadata and index. As soon as a folder is created as a result of FTS index definition, it creates a set of two files. Two files with segment name and possibly one write lock file. This is Lucene metadata, and it does not contain actual AR entry values. Whenever an entry or a batch of entries is created using Lucene API, Lucene will create three files, CFE, CFS, and SI. This set of files is how Lucene manages commits transactions. There may be more than one set of such files, at times 10 to 20 or more sets. Each of them contained one or more entry values with FTS index fields and entry ID. Whenever we use Lucene Commit API, Lucene tries to optimize all three files into a single set of three files. Subsequent searches can then look up on that single set and be returned. These files are completely managed by Lucene, and we have no control over it. Since AR Server version 901 SP1, we have a committer thread for Lucene that runs every minute. Normally, you will see optimizations taking place in different folders at an interval of 1 minute. So in this slide, we'll talk about search and indexing of data. When setting form and field attributes, fields can be set with none, FTS and MFS, or MFS only. The MFS only option affects only global searches. This does not affect workflow or normal user actions. This dictates not only what is indexed, but what is searched. Any field without none defined or with a category name will get indexed, and this is how we make the decision on what gets indexed. So here we see an example of an API SQL log entries from someone modifying a record. We'll talk about the values later, but from here you can see there's a setEntry API call begins. The T-table is updated with the changed data. A new thread to insert the record into the FT pending table uses a separate thread pool with 20 threads in it, once for each indexing server. And a signal is sent to the indexing servers to index the data. The setEntry API call ends, and the record is updated in the collection directory. As mentioned earlier, an indexer thread checks the FT pending table for work. Here we can see an example of an actual query to select entries that still need to be indexed. The indexer thread starts up and checks the FT pending table and performs the index, which then adds the data to the collection directory. Before we take a look at the contents of the FT pending table, you should know there is a primary key on sequence number, server name, and indexer server name. There can be only one sequence number for a server name, indexer server name. Any modify or create entry API calls will create a record in the FT pending table for each indexer server, and each entry receives a new sequence number. The AR server code enforces a new sequence number. We also create a unique index on schema ID, entry ID, and indexer server name. This is a built-in flag to alert AR server that there are two actions for the same record, and it will delete the oldest as mentioned earlier. At the top of the screen, you can see the column headers for the FT pending table. The server name column contains the server name of the server initiating the request. Jobs are inserted by an AR server that needs something indexed. The schema ID column is the schema ID of the form to be indexed. This should always have a value since every index is based on a form. So the field ID is when the job is to reindex a specific field on a form. This is populated with the field ID. The indexer never indexes a single field. It will index all index fields for each record. We index the whole entry, all FTS-enabled fields, rather than just one field that is modified. This provides optimization by eliminating duplicates. You update the entire record once, rather than potentially updating multiple times for different fields. The next column is the entry ID. When the job is to reindex a specific record on a form, this is populated with the entry ID. The entire record, all index field, is reindexed. We need a unique ID to satisfy unique index on FT pending, index server name, schema ID, and entry ID. For uniqueness, we use current epoch time, and if we are inserting multiple entries, we keep adding one to that. So the operation type is the operation for the job to be performed. You can see a list of the operation types to the right of the screen. A full reindex inserts an operation type of 5 for every indexed form. The update time is the time that the record was created. When the item is actively being indexed, this will change a multiple of 5,000 as the indexer updates this value every 5,000 records indexed. An operation type of -1 is when the current record is actively being worked. An operation type of -2 is when the indexing for this record has failed. As mentioned in the previous slide, a unique ID is given to each item. The value will be the max sequence number plus 1. The record will be set to a negative sequence number when the item is actively being worked on. Every ranked indexer will get its own index job for every indexing activity other than a full reindex. A full reindex is performed by server, and this is what you would see in the index server name column. The AIR server column shows the version of the AIR server that requested the index job. And lastly, the count. This is the total count of records to be indexed. This was added in version 9.104 and is used for operation types of 5, 6, and 7. So in this slide, we'll take a look at troubleshooting issues where data is not found. So for MFS global searches, check the multi-form search form manually. So you want to open the MFS multi-form search form using an admin user to avoid permission issues. If you search this form and the item is returned as expected, it's most likely filtered in global search due to row-level security permissions or a published status. If the data is not found, FTS or MFS, check the FT pending table to see if it's waiting to be indexed, and check that the indexing is moving along and keeping up. You can take a look at the AIR FT index log for errors related to this form or record. If data is not indexed, update the index for this record or form. For a specific record, simply update an FT index field on the record. In every case, enable the AIR FT index log to monitor the status. Use the FTS Management Console to check if the server is currently performing a reindex activity. Here we see a screenshot of an FT pending table. And so from this slide, we can see that the operation type is 5 - 5, which means a full reindex is taking place. The records with the operation type of -5 are currently being indexed, and the records with an operation type of 5 are waiting to be indexed. And so as part of troubleshooting, you can check for queue jobs for each indexer server to see how many records are waiting. So in this screenshot, we see an example of a query that you can run that will help you obtain this information. So another troubleshooting step would be to enable API and SQL logs along with full text indexing logging. From these logging examples, you can see the insert into the FT pending table for adding or modifying an FTS field property with an operation type of 7. The next logging example is from the AIR FT index log, which shows a field reindex. So which logs should you review when troubleshooting FTS search and indexing issues? The AIR SQL log will show you search requests and indexing requests, as will the AIR API log. The AIR FTS log will show search requests and indexing requests. The AIR FT index log will show you ongoing index and reindexing. There's an AIR FTS plugin searcher log, which will show you the plugin related information. The AIR FTS searcher log will show you the search request info from the plugin server. And then you also have the AIR FTS plugin searcher standard error and standard out logs, which will show you startup and if potentially the plugin is crashing. And so some troubleshooting techniques that you could do is the first thing would be to validate the configuration. Use the FTS Management Console or the centralized configuration to view the FTS configuration for all servers. Check both the server settings and the plugin server settings. Check the server connect name and make sure that it's the local server name. A server plugin alias should point to the ranked 1 server. The server plugin alias should point to the rank 1 indexer, and the correct port should be listed. You want to check the full text mode to see if it's ranked as an indexer, a searcher, or a standalone server, or a single server. You want to check the full text collection directory and the full text configuration directory and make sure that they're set to the local drive. So for issues where data is not found, check the logs to ensure that FTS was called. The SQL log can be used to confirm that the query was correct. You can check the DB portion and if row level security was used. The AIR FTS searcher log will show you the portion of the query. You can check the AIR FTS searcher log for the phase 1 and phase 2 of the FTS search. The phase 1 goes out and finds all the records that match your search criteria. The second phase does the row level security, where it checks to see of the results found, how many of those records do you have permissions to see. And this may help in identifying if the problem was with permissions. So next we're going to take a look at the FTS Management Console. This console is part of the Server Group Administration Console. It's a single point of configuration for all servers. From this console, you can reindex all forms or a single form, and you can get the status of indexing. So the required permissions to access the console are an AIR System Administrator, AIR System Configuration Administrator, or an Integration Administrator. From the console, you can update FTS configuration for all servers in a server group. You can initiate reindexing for the entire server or for a form. You can check if the reindexing operation is in progress and check the status of the operation. The FTS configuration panel displays the following details as well. If the selected server is FTS indexed, is it just a reader or an indexer? If it is an indexer, whether indexing is enabled or not. And again, whether the reindexing is in progress. So from this slide, we can see that you can initiate reindexing for the entire server or for just a form. And you can select either server or form to trigger the reindex operation. If you choose server, the reindex operations start on all the indexer servers. And for a form, the reindexing operation starts for the selected form on all the indexer servers. So from the top slide, you have an example of how you can select just a form. So from the options here, you would select form. You would scroll down and find your specific form name that you wanted to reindex. Once it was highlighted, click reindex, and the reindexing of just that form would begin. If you wanted to reindex for your indexing servers, you would highlight the server in question, opt for the reindex by server, and then start the reindex. Additionally, you can reindex from the RKM Managed Knowledge Sources console if you wanted to, or you could also reindex using driver. Those are just other options that are out there if you wish to do those. The screenshot seen here in this section of the panel is visible only if the selected server is an FTS indexer and the reindex operation is in progress. This section shows the current status of the reindex process and provides the following details. When the reindex started, how many rows were to be processed, how many rows were processed so far, failures, if any, during the reindex, and the reindexing progress. The Advanced Configuration option for the server group opens when you click the Advanced button on the configuration panel. When you use this option, all the configurations are applied to all the servers in the server group. Data and all the fields on this form are populated from the first indexer server. This slide contains references to knowledge articles and documentations pertaining to FTS indexing. Thank you for attending this presentation of the BMC Helix ITSM and Remedy FTS Technical Deep Dive webinar.